In this example, we are going to solve an exponential equation with two different bases. All right, so here you can see on the left-hand side I have base 3. On the right-hand side I have the base 2. Right, so that is something that we have not done before, except in the case where it was really easy to switch from one base to the other. And by that I mean that one base was a power of the other base, well, a power that was easy to figure out. But in this case, it's not, right? I don't, 2 to what power equals 3, I don't know. 3 to what power equals 2, well, I don't know offhand, okay? It's not an easy switch. So to work this, right, again, I am going to use that conversion from exponential form to logarithmic form. And now this is only one way to do it. There are other ways to do it. So just remember what that conversion is. Y equals log base b of x is the same thing as saying b to the y equals x, okay? All right, and so now you might say, hey, well, this doesn't look quite like this over here, okay? And you'd be right? It doesn't look exactly like the exponential form over here, but I do have either side can kind of be considered as b to the y. You might say, well, which one do I pick, right? In this case, what I would do is just pick the exponent that looks a little bit more complicated. In this case, right, minus 3x plus 2 to solve for that. And so that is the one that I would pick to be the base, okay? All right. So over here, this is going to be my b, this is going to be the y, and this entire thing, right, over here, this entire exponential expression is going to be the 2 to the minus x is going to be my x over here. All right, so I'm going to begin the switch. So the first thing, again, I normally focus on, if you haven't watched those videos about converting back and forth between these two forms, then you probably need to go watch those. So the base of the exponential equation, which I'm using the 3 here, is going to be the base of the logarithm. So that's going to be log base 3, right? Then the exponent, right, of the exponential function is going to be by itself on one side. So in that case, this is the minus 3x plus 2 is the one that I'm using. So that is the y. It's going to come down over here. And then the thing that's on the other side of the equation from the exponential function, in this case that's 2 to the minus x, right, is going to be inside the log, okay? And now that's kind of confusing in this one because of the fact that it in and of itself is an exponential function, right? That kind of makes this problem more difficult than the other ones that we've done because we have two really different bases there. Okay, but you can see I'm just following this pattern. This was my b, this was the y, and this whole side was the x. So just flipped it right on over to that. Okay. All right, so now once you do that, this little x, there's a little extra step right here, and this minus x. Okay, you can use the power rule for logarithms, right? That says, hey, I can bring that exponent down out in front. And so that's exactly what I'm doing, right? I'm using the property of logs, right? That third property, which we refer to as the power rule, that says if I have the log of something and the entire inside is raised to a power, then that power can come down out in front of the log, okay? Okay, so the next thing that we need to do, right, is to get every term, once we've done all that, get every term with an x on one side, every term without an x on the other side, okay? So this minus 3x right here has an x in it. This side has an x in it. And so the quickest way to get every term with an x on one side and every term without the x on the other side is to add 3x to both sides. Okay, so that's what I'm going to do. All right, and I'm going to write that 3x out in front. Okay, and so again, these things you cannot combine. Okay, this term has 3x, and this term has an x, but I'm just not going to be able to combine the log base 3 of 2 with the 3 here. These are like terms, right? But again, adding or subtracting the log base 3 of 2 from 3 is just not going to be easy to do, or something that I want to do. And frankly, I don't have to do it either. So. All right, but I do have all of the x's on one side, all the non-x's on the other side. So the purpose of getting it like that is, even though I can't combine those, I can factor out the x. It's common, right, to both of those terms, the 3x and the x log base 3 of 2. So I can pull it out. All right. And so the last step in solving for x is to divide by what x is being multiplied by, which is this entire expression over here. And I need to do that on both sides. Okay, so my final answer here is, right, these terms over here cancel each other out. And I'm left with x equals 2 over 3 minus log base 3 of 2. Okay, so there we go. We've solved for x. Okay, and so the only other issue, right, is that if you need a decimal representation, right, of this number here. So on Desmos, it's really easy to do, right? It's just 3 minus log base 3 of 2. Okay. So that's our decimal representation, right, of that. So not too bad. The downside is, right, that if you do not, right, have a Desmos to use, then you're using your calculator to get a decimal representation, right? Then there's no log base 3 key on there at all. So what you're going to have to do is use the change of base formula if you use the approach that I showed you. And so that would be ln of 2 divided by ln of 3. Right? You would have to replace log base 3 of 2, right? It would be natural log of the argument of the log up here divided by natural log of the base, like that. And again, I can pull that up on calculator and just kind of show you how that's done. All right, so it would be 2 divided by open parentheses and then 3 minus natural log 2 divided by natural log 3. Right, and you can see we come up with the same answer there. All right. So there is an alternative way of doing this, right? You could just take the ln of both sides. I'm not going to work through that full way of doing that, but just to let you know that it's out there, right? And because you will see other people work it out that way. So their next step would be to take the ln of both sides, or their first step rather, would be to take the ln of both sides like this. Okay, and then use the power rule for logarithms, right, to bring these exponents down. So it'd be minus 3x plus 2 times ln 3 minus x times ln 2, like so. And then do the algebra, right, to solve for x. And when you do that, you're going to wind up with something that looks very, very similar to this expression right over here. Well, that's a perfectly acceptable and fine way to do the problem. The only downside I see to this, it's good to know how to do it both ways, right? But the downside to this is that the algebra is going to be more complicated. Here, I don't think the algebra was too bad. I think it's slightly simpler this way. Okay, so that's the reason why I explained it this way and not this way. So you're free to use whichever way you want to, whichever way you find is simpler to do the problem. That's the way you should do it, as long as you're getting the correct answers.